These are the homework solutions for 13.3, the B and C level problems. Although I did throw in an explanation of number 9 because that could be a little tricky. I think some of you guys were having trouble with that one in class. So you're given 3 points. You're given point R, which is -3, -4. You're given point S, which is 2, 2, and you're given point T, which is 14, -8. And what you have to do is show that it's a right triangle. The way I'm going to show that it's a right triangle is show that 2 of those lines are perpendicular. So I actually plotted this on a piece of paper to make it easier to see. But I'm going to find the slope of RS, and I'm going to compare it to the slope of ST. Now, if you didn't draw the picture, you'd have to find the slopes of all 3 and figure out which 2 were negative reciprocals of each other, and then the slopes were negative reciprocals of each other, and then those would be your parallel lines. But anyways, it's pretty clear here that RS is parallel to ST, but I actually have to show that mathematically. So I do want to find the slope of RS. So the slope of RS is rise over run, delta y over delta x, formula y2 minus y1 over x2 minus x1. All right, 2 minus a -4 divided by 2 minus a -3. 2 minus a -4 divided by 2 minus a -3. 2 plus 4 over 2 plus 3, which is 6/5. Okay, now using the same formula to find the slope of ST. Remember, slope rise over run, delta y over delta x. The delta, Greek letter for D, difference. So y2 minus y1, that's where the minus sign comes in. x2 minus x1. Okay, so here we go. 2 minus a -8 over 2 minus 14. 2 minus a -8 is 2 plus 8. 2 minus 14 is -12. 2 plus 8 is 10. 10 over -12, that's -5/6. Now, what I want you to notice here is the slope of RS is 6/5. The slope of ST is -5/6. So you can see when I multiply those guys together, I get -1. Thus, RS perpendicular to ST. All right, that's 9. Here's 15. 15, they give you 4 points, H, I, J, and K. And what you have to do is figure out what type of special quadrilateral it is. So what I did was I plotted the points, and then I calculated the slope of each of the lines. So let's look at this slope here. Okay, so this is a horizontal line, so its slope is 0. This is a horizontal line, its slope is 0. That's really nice that they gave 2 of us. 2 of the lines are horizontal. Don't have to do that much calculation. Now, this point here is 1, 9, so the slope of this line right here from H to K, well, let's see, the rise is going to be 9, up 9 over 1, rise over run, 9 over 1. So the slope of this line, HK, is 9 over 1. The slope of this guy, well, it's up 9, and this time it's over 2. So 9, 2 is the slope from J to I. So I'm looking at this thing, and I'm noticing that I have 2 slopes that are the same, these horizontal lines with the same slope, and 2 slopes that are different. And so there's only one figure that I know of that has that's a 4-sided figure with 2 lines parallel, and that is a trapezoid. So thus, HIJK is a trapezoid with 1 pair of sides parallel. All right, that's 15. 20, you get to see this fantastic circle that I drew. Okay, so 20, here's the problem statement. Point P, and P is 6, 7, lies on a circle. Okay, here's 6, 7. This is a point on a circle. The circle is x plus 2 quantity squared plus y minus 1 quantity squared equals 100. So x plus 2 quantity squared minus y minus 1 quantity squared equals 100. And what we have to do is find the slope of the line that is tangent to the circle at this point here, right here, this P. All right, so I'm trying to find the slope of this line right here that I'm just drawing in. Well, this hinges on the fact that when I have a tangent line and it's tangent to a radius at a single point, the radius and the tangent line are perpendicular. So if somehow I can find the slope of the radius, then I can use the fact that perpendicular lines have slopes that are negative reciprocals of each other. I can use that fact to figure out the slope of the tangent line. So I need to find the slope of the radius. Well, I have one point, 6, 7, but to find the slope, I need another point. And the way I'm going to get this other point here, every radius goes from the center of the circle to a point on the circumference. So I need to look at the equation of the circle and find out what the center of the circle is. All right, so here is my equation. X plus 2 squared plus y minus 1 squared equals 100. Now the general equation of a circle is x minus h squared plus y minus k squared equals r squared. All right, so getting r squared, getting what r is easy. I can set r squared equal to 100. With r squared equal to 100, and then r is 10. So I know my radius is 10 units long, which really actually is a piece of extra information for this problem, so I don't really need that information. Now, I know that x plus 2, quantity squared, that's the x minus h part of the equation. So looking at this here, I have x. Okay, here I have a plus, here I have a minus. I need to look at this and somehow figure out a way to make it fit this pattern. And I know that if I subtract a negative sign minus a negative sign, that gives me a positive. So really what this means is x minus a negative 2. So h has to equal negative 2. Now looking at trying to figure out what k is, because remember hk is the center of a circle. I know that y minus 1, quantity squared, that's this part of the equation, y minus k, quantity squared. So I can look at this, the pattern is the same here, y minus k. It's really easy to see here that k is equal to k is equal to 1, excuse me. So I know that h is negative 2 and k is 1. So the center of my circle here is 2, negative 2, 1. So this point right here, negative 2, 1. Now I've done the hard part. I can find the slope of this radius. The slope is equal to the rise over the run, delta y over delta x. 7 minus 1 divided by 6 minus a negative 2. That 7 minus 1 is 6. 6 minus a negative 2 is 8, so that's 3/4 when I reduce it. So now I know that this slope is 3/4, so the slope of the tangent line is reciprocal of the negative reciprocal of 3/4. So the line tangent to a radius is perpendicular to the radius. The slope of the radius we figured was 3/4, so the slope of the tangent line is negative 4/3. And just to convince you further, 3/4 times negative 4/3 is equal to negative 1. All right, that is 20. Last one, 21. This actually isn't that hard of a problem. It's an interesting problem, but the words get in the way. So I think that that's the problem with this one. 21 says, use the algebraic definition to classify each statement as true or false. The algebraic definition of what? The algebraic definition of slopes. So remember, the algebraic definition of slopes, and I'm going to read to you from page 535. Two non-vertical lines are parallel if and only if their slopes are equal. So that's the algebraic definition of slope. Okay, so 21a says this. For any line, L, in a plane, L is parallel to itself. So we know that the slope of a line is always equal to itself. That's the reflexive property, right? A equals A. So if the slope of a line is equal to itself algebraically, then L is always parallel to itself. So reflexive property applies to slopes and parallel lines. Okay, part B. if L parallel to N, then N parallel to L. So let's translate that into the algebraic definition. If the slope of L equals the slope of N, then is it true that the slope of N equals the slope of L? Well, things are equal. If A equals B, then B equals A. That's just the symmetric property. And so that makes that true for this whole idea of slope. If one slope of one line, L, is, I said that all wrong. If line L is parallel to line N, then N is parallel to L. All right, the last one. If K is parallel to L and L is parallel to N, then is it true that K is parallel to N? So let's translate it again into our algebraic definition language. So what we're saying is, if the slope of K equals the slope of L, and the slope of L equals the slope of N, then the slope of K equals the slope of N. Okay, these are just two quantities we're comparing to each other, and by the transitive property, if A equals B and B equals C, then A equals C, I can say that this entire statement here is true. And that is it. Oh, goodness gracious.